Hello everybody, this is the notes for Algebra 2 Trig, section 4.4. This is the last section that we're going to be doing for this chapter. As you can see from the title, we're going to be solving systems using matrix equations. We talked about solving systems a lot with chapter, I believe it was chapter 3, elimination method, substitution method, graphing. There's other methods that you can use. They kind of revolve around matrix equations. There's a couple different ways you can do them with matrices. Matrix equations is one of the ways. We won't be talking about the other ones. It's kind of nice, but it takes a lot of explaining to get to it. So, all right, the idea of a matrix equation. That is a matrix equation. That's a terrible arrow. There we go. That's even worse. That's a matrix equation. AX equals B. So I'll explain what the A and the X and the B represent in a little bit. But here's the idea of matrix equations and how to solve them and how we're going to use them. So looking over here at the left side, real numbers. If we're going to solve this AX equals B, if we're going to solve that equation for X, normally we would just divide by X. With matrices, we've talked about adding and subtracting and multiplying matrices. We have not said anything about division. So, we haven't said anything because you can't. You can't divide a matrix by another matrix. So, what we're going to do is to solve this real number equation without division. That means we're going to multiply by the reciprocal. So 1 over A times AX equals, you got to multiply the other side by 1 over A also. So if we group these together, 1 over A times A, well, that's just 1 times X. And I'm just going to leave these 1 over A times B. I'm going to leave them separate. But 1 times X is just X. So we have solved for X without using division. Okay, this 1 over A that we used here, that's the reciprocal. We don't really have reciprocals for matrices. So looking over here at the matrix equation on the right side of the screen, we want to solve for X. X is going to be where our variables are at. And so we got to get rid of this A. We can't divide by A because we just can't divide matrices. So we need to cancel it out. That's where the inverses come in. If we multiply both sides by A inverse and group those together, A inverse times matrix A, that's the identity matrix. Okay, the identity matrix times X is just matrix X, and that equals A inverse times B. This is the key part of your notes, that equation right there. X equals A inverse times B. And it's got to be in that order. You have to do A inverse first and then multiply it by B. So, what in the heck are A, X, and B? That's this stuff. So we're talking about solving a system. All right, we're going to take our system of equations and break it up into 3 variables. The coefficient matrix, that's our A. The variable matrix, that was our X. The constant matrix, that's going to be our B that we just talked about in the last screen. So the coefficient matrix, coefficients are just how many of each variable. So make sure your equations are perfectly lined up. X's, Y's, equal sign, constants. Okay. Any equation you have, make sure everything's lined up. So the coefficient matrix is just the coefficients, 8, 7, 4, -9. There's matrix A. The variable matrix, okay, again, the equation was A times X equals B. So we're multiplying A and X. Remember, to multiply matrices, the inner dimensions have to be the same. Right now, this is a 2 by 2. So the variable matrix, it has to be a 2 by something. Well, we've only got 2 variables, X and Y, but it's got to have 2 rows. So we're going to organize it like this. Oops, not 7. Y. It's going to be a 2 by 1. Okay? Your variable matrix, it is always going to be a certain number of rows by 1 column, always. Okay, that's your variable matrix. The constant matrix, well, if we're going to multiply a 2 by 2 by a 2 by 1, remember the outer dimensions are the size of your answer. So our constant matrix in this case is going to be a 2 by 1. That's just what the equations equal, 5 and 63. Okay, here is our A, X, and B matrices. Now, to solve for matrix X, that we're going to do A inverse times B. This is how we can use matrices to solve systems of equations. We're not going to solve that one. Let's look at this one. So we're going to turn this into a matrix. 2, negative 5, 3, 4. X and Y is a 2 by 1 matrix equals the constants, negative 19 and 6. Okay, so before we go through and get the calculator out and solve this, I just want you to pay attention to what is going on here and why these things work or how it's set up. If I were to multiply by hand matrix A and matrix X, you do row by column. So we would have 2 times X plus the negative 5 times Y. Do the second row times the first column, the XY column. So we'd have 3 times X plus 4 times Y. Okay? This 2X plus the negative 5Y, that was the first row, first column. That equals first row, first column of matrix B. 3X plus 4Y, that was the second row times the first column. So that's the second row, first column, which is 6. So by doing the matrix multiplication by hand, we're getting our system. So we're just going backwards to put it into the matrices. All right. It's not a big deal. We don't need to do that every time, but I just wanted to show why this stuff works and where these matrices are coming from with this equation stuff. All right. So to solve this, need to get out the calculator. There we go. There we are. Okay, so turn the calculator on, clear whatever is there, go to matrix. I'm going to enter in matrix A, which is a 2 by 2 matrix. 2, negative 5, 3, and 4. Okay, I get out of there, I go back to matrix. Now I want to enter in matrix B, which is a 2 by 1. And we have a negative 19 and 6. Okay. So get out of there, go back to matrices. Anytime you want to do something with a matrix, you go to names. To solve for matrix X, Y, the variable matrix, we are going to do A inverse times B. So we have entered in A, we have entered in B, so we need A inverse multiplied by matrix B, and we hit enter. And you notice it's in the exact same format as the XY variable. Negative 2, 3. Okay, 2 matrices are equal if all the corresponding matrices are equal. So that means is we're looking at X is 2, Y is 3. So the answer to this system is negative 2, 3. Okay, there's a system of equations solved. Kind of convenient. Now, this was a fairly simple system. We could have done an elimination method or substitution method probably in the same amount of time. So why would we be spending our time doing this? It comes into play when you have bigger systems, more variables, more equations. So to solve this one, now, I don't think I'm going to solve it just because of the time. You're just entering in matrices. That's what takes the longest time. What I do want to go through is setting up the matrices. So matrix A is your coefficient matrix. Everything is lined up, X's and Y's and Z's. So negative 3, 6, negative 4. The second row is from the second equation. 1, negative 4, 2. Notice in the third equation, there are no X's. My first column is the X's, so we need a placeholder. There are 0 X's. 8Y, negative 1 for Z. This is matrix A. But now we've got 3 variables. So our variable matrix is X, Y, and Z. Equals the constants, which will also be a 3 by 1, 8, -3, and 0. All right, so to solve for x, y, and z, you do the exact same thing. This is matrix A. This is matrix B. You're going to do A inverse times B. So you just go into your calculator, you enter in matrix A, it's a 3 by 3, you enter in matrix B, and you go to names, you do A inverse times B, and you've got your solution. So, when we solved equations, some of them had solutions. You got an answer for a value of x and y. Some of them didn't have solutions, or they had an infinite number of solutions. So, with a calculator, when you're doing this matrix equation stuff, if something goes wrong, you're probably going to get this. It's going to be an error, and it's going to say singular mat, short for singular matrix. A singular matrix is one that doesn't have an inverse. It's a technical name. You don't need to worry about it, but that's where it's coming from. So basically, there's no inverse for matrix A. You're trying to solve it by using A inverse times B. Well, if there's no inverse, you can't multiply A inverse times B. So that means there's no unique solution, meaning you're not getting an answer. It's not one of those independent systems. That leaves it to be either a dependent system or an inconsistent system. How to tell which one? Well, you got to start paying attention to what does your equations give you. Look at the graph of it. Look at, if you just got two variables, your x and y variables, are the lines parallel? Are the lines exactly the same thing? That's going to tell you, if the lines are the same thing, it's going to tell you dependent. If the lines are parallel, that's telling you inconsistent. If you have one of those one of the equations like we just did here, where you got the 3 variables, if you tried to graph each of those equations, that's really a plane in 3-dimensional space. That's something completely different. All you're going to say is no solution. Okay, that system just doesn't have a solution, so we're not really talking about dependent and inconsistent. And really, those terms, the independent, dependent, inconsistent, that was from linear equations with 2 variables. So those terms really don't even come into play when you have the 3 equations. All right, that is it. Hope you have a good night. See you in class Friday.